Now this is the one method that we actually learned to take a limit at the end of this section, and it's going to be the same thing at the beginning of the next section. And it almost seems like it's not worth calling it by a special name, but it's called direct substitution. And what it is if you have a continuous function, or at least it's continuous at that value, x equals 4, then the way you find the limit of the function is you just plug in that value for x in the function. Right, so in this problem here, I would say, if I can plug it in and it doesn't lead to a divide by 0, then plug it in. And the answer is 16. Right? If you can plug in the c into the function and it's defined, then you're good. Just plug it in. It seems like it's kind of, like I say, does that really need a name? But we'll use it a lot, because generally what you do when you get a limit is the first thing you do is you see, does direct substitution work? Okay, well you'll see in the next section, it almost never does, right? And then you got to apply some other method. And then you say, okay, after I apply the method, does direct substitution work? And if it does, then you finish it off with direct substitution. Right? So that's the check that you always make, because if you can plug it in, then you just do it and you're done. Most of the time what you get, it's like the first example that we did, that if you plug it in, you get 0 over 0, which is called an indeterminate form. When you get that, you say, okay, I'm going to have to do one of my strategies to get rid of that, and then I'll try direct substitution again until it works.